Welcome to Lesson 6, and this lesson deals with Object-Oriented Programming, or OOP. And this part, I want to spend a few minutes just going over the principles of OOP, or Object-Oriented Programming. Now you're going to come across lots of different terms and terminology, and I suggest you take note of these terms or terminology. When you're reading books or reading programs, you'd understand the language of object-oriented programming, and the only way you're going to understand that if you understand some of the terms, unique terms that we use in OOP. Now some of the terms or terminology that we use in OOP are not unique to Swift. They are terms that are generally used in any object-oriented programming like C++ or Java or C#. But there are some specific terms that only Swift uses, and I'll highlight these terms as we move along through this lesson, Lesson 6, Part A. So this lesson just consists of some slides where I go over the principles of object-oriented programming. So OOP, or object-oriented programming. So let's have a look at this first slide. Look at the picture on the right hand side. Here, before I could manufacture my cars, which are the objects, I need to have some sort of blueprint or design or template or pattern in order to manufacture the cars. So before we create objects in programming, we have to have something called a class. So if I could define what a class is the template or the pattern for creating objects. So we create objects from the class. The class is created first and the objects are created from the class. Or another way of saying it, it is the blueprint or specifications. We could also say that a class is a set of objects of the same type, or in other words, it is the object's type. So in this example, these cars that have been manufactured, they belong to the type class or car class. The car class being the type of the object that you create. Now once you've got the class, you then create the objects. So the formal definition of an object is it's a programming representation of real world things. So whenever we program or make a software code, we always look at what we are trying to model or what real world objects we are trying to represent in a binary form or encoded form in our program. We always get our ideas from real world objects. So as I said, objects are made from classes, or another way of saying it, objects are instances of a class. Now I know this is a lot of theory. I will be taking some real world examples in the next few minutes, and it will become clear to you once we use some examples. Another way of looking at it, I'm sure all of you as kids helped your mum to make cookies or biscuits. Now how do you make a biscuit or cookies? You first have to create the dough by using some flour, eggs, milk. So once you've created the dough, you then need a cookie cutter to cut out. So the cookie cutter is like a pattern that you're going to use to create these biscuits or cookies. So think of the cookie cutter as being your class, and you use the cookie cutter to make your individual cookies, and these individual cookies are the objects that you make from the pattern, the cookie cutter. A few things to remember before we move on to creating objects. Before you create the objects, you have to create the class. A class has to be created first, and then the objects are made. Now, how do we start off by making a class? We do this by modeling an object. So we take a real world object, physical object, and we model it. Now, how do we model it? We examine all its attributes and its behaviors. So this entails examining the attributes and the behaviors of the object. Let's take an example. Let's suppose that we want to create a game that's going to have a lot of people in our game. So before we create people objects, we need to create a class called a person. Now, when we examine a person, we need to find out what are the attributes of a person before we can create a person. The attributes, one of his attributes could be the name, the other one could be gender, whether it's male or female, and the other one could be his weight, and another attribute of this person could be his profession. So we've listed 4 of the attributes of this person. Now that will go into the class. Once we create the class, we can then create different people or different objects, and each object will have its own unique name, own gender, own weight, and own profession. Now we are just creating the blueprint or the template for creating the objects. So those were the attributes of the person object. Now, we also examine some of the behaviors of a human being or person. What does he do? What actions does he perform? Well, some of the behaviors that a human being does or person does. He eats, okay, so he does eating. He does exercising. He does work or working. And he does relaxing. Now you'll notice that when we look at the behaviors, they are action words, or sometimes we use verbs to describe them because they are actions. And the attributes are generally nouns. Okay, name, gender, weight, profession are nouns, and behaviors are normally action words or verbs. Now, attributes are also known as properties of the object, or we can sometimes say attributes are the state of the objects, and we generally use nouns to define the properties or the attributes or the state of the object. Behaviors define the actions that objects perform, and generally we use verbs or words that denote action. Now, once we take an object and define its attributes or its behavior, and we put that together, okay, so the process of combining the attributes and behavior of an object and packaging that together is a term we call encapsulation. So encapsulation is the process of combining the attributes and behaviors of an object into a class. Now, generally in programming scenarios, the behaviors will have some effect on the attributes. For example, in the person class that we created a few minutes ago, or we spoke about a few minutes ago, the amount of exercising and eating will affect the person's weight. So remember, exercising was one of the behaviors, and eating was also one of the behaviors. Those were verbs or actions. The amount of exercising and eating will affect some of the attributes, and in this case, exercising and eating will affect the person's weight. As another example, working or work was another behavior, and that could be linked, or that could affect the person's profession. So the type of work you do will be linked to what profession you have. So the point I'm trying to make here is that normally in programming, the behaviors or the actions have some effect on the attributes of the object. Let's take another example. Suppose I want to create cars as objects. So before I create the car as the object, I need to create the class. So when I want to create the class, I look at a normal car in the real world, on the physical world, and I try and find out what are some of its attributes. Okay, it would have a make, like a Toyota or a BMW. It will have a color, red, green, blue. It will have a speed, that average speed that it does, and it will have a plate number. Now these are generic attributes, but when we do create the real car, each real car will be unique. It will have a different plate number. It may have a different make and model and color and speed. These are just the generic attributes of car. It will also have behaviors, like you can open the door of a car, you could start the car, you could accelerate the car, and you can also stop the car. You'll also notice that some of the behaviors have an effect on the attributes. The amount of acceleration, which is a behavior, will have an effect on the speed at any instant in time. The more you accelerate, the higher the speed. So generally in programming, behaviors work on the attributes or have some effect on the attributes. Now let's take another example. Suppose I want to model a real world door in programming. So I'm creating a game, I want to create a door in my game. So I look in the real world and I try and find out, okay, in the real world, what would be the attributes of a door? Okay, I've chosen 6 attributes. It would have a width, it would have a height, it would have a weight, it will have a color, and we can determine whether the door is opened, yes or no, and whether the door is closed, yes or no. Now have a look at how I've specified the attributes. I've given the attribute name, and next to it I put down what the type is. If I have to model this, if I have to convert this into a computer program, I need to now start thinking about what would be the type of each one of these attributes. So if I define a variable called width, I'd like to store the width in the form of an integer as a variable. So I've given width to be integer, height to be integer, weight to be integer, and the color of the door, either blue, green, or brown, that's going to be a string. And opened is going to be boolean or bool, either it's yes or no, and also closed is going to be bool, yes or no. Let's look at the behaviors of the door. I can open the door, I can close the door, I can lock the door, and I can unlock the door. Right? And I said to you, behaviors normally have effects on the attributes. So if I open the door, the opened attribute will be yes, door is opened. If I close the door, the opened attribute will be no, because the door will be not opened. If I lock the door, if I open the door, the closed attribute will be no. If I close the door, the closed attribute will be yes. If I locked the door, then the opened attribute will be no. If I unlocked the door, the opened attribute will be yes. So the point I'm making is that the open, close, lock and unlock behaviors will have some effect on the attributes. I also mentioned to you that the terminology that we use are general terminology that we use in most object-oriented programming languages, but in the case of Swift has some very specific terminology, and you need to be aware of this. The attributes are not called attributes in Swift, they are called properties. The properties can be constants and variables of any type, such as integer, string, double, etc. So important point here is attributes are called properties in Swift. The behaviors are called methods in Swift, and these are normally functions that we studied in lesson 5. So if you understand functions very well from lesson 5, you should have no problem understanding what methods are. So key takeaway here on this slide, attributes are called properties and behaviors are called methods. Thank you for watching this part of lesson 6, and when we get back we'll get stuck into the programming, and I'll show you how to create classes, and I'll show you how to create objects from those classes.